everybody, it's Mr. V, and today we're going to be making ice cream. Alright, so before we dive into making ice cream, I wanted to talk about the chemistry of ice cream so that it helps us understand the structure better. So this is from the American Chemical Society from Chem Matters, and I recommend that you click download this article and then it'll take you to this page that's easier to read, that's nicer to read. So the first thing I wanted to point out was how air is very important. So we don't usually think about air, but in ice cream, air takes up about 30% to 50% of the total volume in ice cream. And so that's why if you ever melted ice cream and then you try to freeze it again, it doesn't taste as good later because all that air has escaped from the ice cream. Okay, and the next important part is about how ice cream is an emulsion. What an emulsion is pretty much just a combination of two liquids that don't normally mix together, okay, and instead one of the liquids is dispersed throughout the other so that they're evenly mixed. All right, next we have this lovely diagram that helps us break down the components of ice cream. So there's three main components of ice cream on this diagram. So there's ice crystals, which are the water, and then air cells and the fat globules or the fat particles. So just wanted to review that ice crystals, these water molecules are considered polar, and then these fat globules are considered non-polar, which means that those two aren't going to want to mix together. So even if we try to mix them together, over time they're going to separate. But if you want that nice ice cream texture, we're going to need them to mix together. So we got to figure out some way to keep it all together for ice cream. The next part I want to talk about is these ice crystals over here. So we want these ice crystals, when the liquid water becomes frozen, we want these ice crystals to be as small as possible because if it's too big, it's going to taste too crunchy. It's going to taste like you're crunching down on ice. And for ice cream, we want it to be very soft. So we want these ice crystals to be as small as possible. Okay, and there's going to be two ways that we can do this. So the first way is to add an emulsifier. So one example of an emulsifier for this is like adding an egg. The function of an emulsifier is that it helps mix together the polar and the non-polar substances together. So in this case, the emulsifier helps mix together the ice crystals and the fat globules together. And so this way, since they're all like mixed together, you're not going to have these huge ice crystals forming because they're all mixed throughout. The second way is if we freeze it really fast, you're going to get really small ice crystals instead of really huge ones that form. So when we make the ice cream today, we're actually going to do the second method where we're going to try to freeze the ice cream really fast. We want it to freeze fast so that it gets that nice creamy, smooth texture. Unfortunately, we're not going to be working with liquid nitrogen. If we had liquid nitrogen, we wouldn't be able to make it like super smooth and creamy texture, but it's okay. It's still going to taste good. All right, so how are we going to freeze it really fast? We're going to use some chemistry, and this is going to be called freezing point depression. So freezing point depression is when you mix salt and ice together, and when we do that, it lowers the temperature that ice freezes at. So usually ice freezes at 0 degrees Celsius, but we can lower that temperature, and if we add salt and we mix it together, it could freeze at like -3 degrees Celsius instead. That's the strategy that we're going to be using to help freeze the ice cream really fast. And by doing this, by freezing it really fast, we're allowing these ice crystals to be as small as possible. All right, so by having these really small ice crystals spread throughout the whole solution, this helps lock everything in place so that we have a nice mixture of the ice crystals and the fat globules and the air cells all mixed together with the right ratio, and so that they don't separate into different pieces. Alright, so for toppings, one of my favorites is crushed Oreo. So all you need is to take a regular Oreo, put it in a Ziploc bag, and then I like to use like a hard plastic water bottle, and then all you have to do is just smash it away take all that stress that's been lingering inside you, let it flow through your hands, and just let it all out. Alright, I know the topping that I like to add in my ice cream is strawberries, so I already washed these, and so I'm just gonna cut them into diced pieces. Alright, so we got nice diced strawberries in a bowl. Alright, so for materials, for the super cold ice, we're gonna need 4 cups of ice, and we're gonna need a half a cup of salt. And we need a large gallon-sized Ziploc bag or any large container that can fit 4 cups of ice, and we're gonna be shaking this. Also, for the ice cream batter, there's 2 types of flavors you can do. If you want to do a chocolate flavor, it's really easy. All you need to have is chocolate milk and a small Ziploc bag, and that's all you need. This is going to become ice cream. If you want a vanilla flavored ice cream, you're going to need 1 cup of milk. I believe you can also use any kind of milk. It doesn't have to be dairy milk. It could be almond milk, soy milk. Yeah, so you're going to need 1 cup of milk, and you're going to need 2 tablespoons of sugar and a half a teaspoon of vanilla extract. And you're going to mix them together. Okay, so to make ice cream, we got to make the ice cream, we got to have a temperature that's really, really cold, so colder than 0 degrees Celsius or lower than 32 degrees Fahrenheit. So right now this is 76.5 degrees in room temperature. If I stick this into the ice, we're gonna measure the temperature. 32 degrees Fahrenheit, okay, is gonna be freezing temperature. I can switch this to Celsius. Scientists like Celsius, but in Celsius, it's almost 0 degrees Celsius. This is negative 0.5 degrees Celsius, negative 0.2 degrees Celsius. So that's as expected. Okay, so what we're gonna do is we're gonna put this into the ice. We're gonna pour that into the giant gallon Ziploc bag. Don't pour all of the ice yet. I'm gonna pour like a little bit, and I'm gonna layer it with some salt. So we haven't learned this yet, but in chemistry there's something called freezing point depression that helps lower the temperature of the freezing point so that it could be colder than 0 degrees Celsius. So just layer it with some ice and salt, and I'm gonna continue that process. I'm gonna add more ice, layer it with some more salt, and mix that a little bit. Okay, same process, more ice, more salt. Put all the ice in there. I'm going to put all the salt in there. Alright, so I'm going to make sure I mix that so it's all layered. Okay, next step is you're going to do, in the small Ziploc bag, you're going to put the chocolate milk. Okay, then you're going to zip it up, make sure you're careful not to spill. Make sure it's completely zipped because we don't want this to leak everywhere in the giant bag. You can also wear gloves so that your hands don't get too cold. Okay, and so now we're just going to, now the fun part is we're gonna shake it for about 10 minutes. Okay, so I'm gonna go ahead and get gloves. Alright, so now my favorite part is we're gonna shake this together. Alright, I'm starting to feel it become solidified a little bit, so this is exciting. Also, this is my very first time making ice cream like this. I've made it before using liquid nitrogen, but I've never did it the old school style. So I wanted to talk about some chemistry as we were doing this. So let me go ahead and temporarily just measure the temperature. Okay, it's like negative 11 degrees Celsius. So notice it's a way colder temperature than normal ice. That's because the salt, it interacts with it at a molecular level. Okay, and in Fahrenheit, by the way, 32 degrees Fahrenheit is freezing point. In Fahrenheit, it's 15 to 13 degrees, so like well below the freezing point. You know, it's actually pretty solidified. I'm gonna shake it for longer, but it's starting to feel like ice cream. All right, so notice the ice cream is bathing in the cold ice bath. This whole liquid and the ice itself, all that temperature is around negative, 10 degrees Celsius or 12 degrees Fahrenheit. So way below freezing temperature. And so this is perfect to allow the ice cream to solidify a little bit. All right, everybody, time for the moment of truth. All right, how does that look? Okay, totally solidified. Oh, also be careful about the fake videos out there. I don't know, there's some fake cooking videos out there where they're like, this is so easy to do, and then they just buy a pre-made ice cream instead. But this is authentic. I know it's not perfect, but this came from this chocolate milk right here. This is Nesquik chocolate milk. These are the cut strawberries from earlier, and the crushed Oreo from earlier. Okay, so now we're just gonna put them together. Okay, I'm gonna sprinkle in some Oreos. All right, how's that look?
Wow, even better than Mama. Keep it up.
All right, time for the moment of truth. Yep, it tastes like chocolate ice cream. I mean, it's not the best chocolate ice cream I've had. This is pretty good for homemade ice cream. I like it a lot. All right, everybody, thanks for watching. Hope you enjoyed this. I'll see you all next time.